Unit 1.14, infinite limits and vertical asymptotes. Use the function f of x to answer the following. Identify all vertical asymptotes. So we factored out this function, we removed the whole, we cancel these out, and that leaves the vertical asymptote to be x equals 3. Evaluate the limit as x approaches 3 from the left. So this right here is a rough sketch of what the graph should look like. It's an asymptote as x equals 3. It's an infinite discontinuity right here. So we're approaching it from 3. So our graph is approaching 3 from the left. Our graph is approaching negative infinity. Vice versa, approaching 3 from the right is approaching positive infinity. Now to do it without the without the graph. So to find the limit right here, we want to draw our number line just for visualization. Approaches 3 from the right. So we want to pick a number that's really close to 3, that's a little bit bigger. So we chose 3.001. We plugged it in place of x on this equation, on this function, and we found this to be negative 2.001 over 0.001, and this is equal to negative infinity. So we know the limit is negative infinity. Right here, we're going to do the same thing. First, we want to factor the equation. Then, since this is asking for on either side, we're going to have to do both instead of just one side like we did here. So first, I'm going to go with, we have to check both sides. So limit as x approaches 1 on the right, we're going to go with 1.001 minus 3 over 1.001 minus 1 squared. And this is about negative 1.999 over 0.001 squared, which is to negative, so we know that it's negative infinity. Now to check it from the left side, limit f of x as x approaches 1 from the left, we're going to go with 0.999 minus 3 over 0.999 minus 1 squared. This is negative 2.001 over negative 0.001 squared. This is going to become a positive since it's squared. So we also know that this is negative infinity, and then we know, since both match, we know that the limit right here equals negative infinity.